All right, one more example of logarithms, example 5C. Similar to the previous, watch them in sequence. Watch these videos in sequence. They build on each other, all right? Put a lot of time into putting them in order so they could build upon each other. Finding the inverse of a function again, which one more time would be a flashback to assignment 21. Assignment 21, finding the inverse of a function. Pretty sure that's the assignment it was. I keep saying it, I hope I'm right. All right, take it out of functional notation. Change the function into y. All right, you got to remember that the variable y and the label f of x, g of x, h of x, those are interchangeable. We switch the variables. My attempt at explaining this was the one where we did the Celsius, Fahrenheit, and the Scottish weatherman, if that helps you remember. All right? And then in this new equation that we just formulated, y needs to be isolated. Solve for y. I'm giving you the ones where y is in one term. That's the easier kind of equation to solve. We've seen many times. In the order of operations over here, what's the furthest operation from y? Indeed, the add 11. So we'll subtract 11 from both sides. And now the equation becomes, I'll pull this up here, x minus 11 equals 4 times, or not times, to the power of, that's important, it's not times, it's raised to the power of 3y minus 2. And if I were to now ask you, what's the furthest operation, what's the furthest entity, what's the furthest thing from the y, I hope you would say, well, that 4 is sitting there. And that 4 is a base. So again, this becomes more and more familiar to us each time we do one of these. I hope you would realize that by me labeling that 4 as being a base, you're like, oh yeah, we got a base raised to an exponent equals something. This equation right now is in exponential form. And its inverse is to change it over to logarithmic. Yes, all right. So every logarithm has a base. The base of your log is whatever the base was up there. In this case, 4. And then again, following that pattern that we practiced multiple times on examples 1 and 2, wouldn't that be of x minus 11? Let's put it in parentheses. It doesn't apply just to the x. It applies to the whole thing. And then that would equal 3y minus 2. Again, remember that the exponent always ends up by itself. The exponent always ends up by itself when you change it over. So that would be the corresponding logarithmic expression for that exponential that we had in the previous step. And I like to think that what's left is just formality. Continuing on, isolating y, we'll add 2 to both sides. So just tack a plus 2 on the end of this. And then we'll get rid of the 3 since it's multiplication with division. Put the whole thing over 3. Whatever you do to one side of an equation, do it to the entire other side. Put that whole thing over 3. And that'll be y equals, won't it? And then, just to wrap it up, what we should now technically do is express that new variable y as a function. So you look back at the original and you say, well, that y back there was h of x. So this one should be expressed as h inverse of x. This tells the viewer that this formula here is the reverse process of the original. And we just copy it down. And this is some really good math, isn't it? All right, so there you go with that. I guess we'll wrap it up. You can quit watching now if you want. That should be everything to help you do assignment number 26. And so again, I'll point out that whole thing had to do with logarithms. And like I said, you can quit watching if you want. But if you want to watch something about logarithms, I don't know, maybe you'll enjoy this. So logs would be the foundation of this.
Hey kid, you want a toy? How about a bite? pick a toy.
I want log. Boy, oh boy.
Yes, log. All kids love log.
Log rolls downstairs, no longer in pairs, rolls over your neighbor's dog. Let's wait for a snack, it fits on your back. It's log, log, log. It's log, log. It's big, it's heavy, it's black. It's log, log. It's better than that, it's good. Everyone wants a log. You're gonna love it long. You wanna get your log. Everyone needs a log.
Log from Lamo.
All right, going a little stir crazy here, folks. I miss you. Have fun with those logs. Go get them.